has to have a conductor to like pass through stuff.
Okay, so there has to be a conductor. Can we add on to that? Because I think, yes, that's one of the parts, that there has to be a part that is a conductor. And?
So, I think there are two wires that connect to the positive and negative side.
Okay, so there's a positive and negative side. So we're answering the question about how a circuit works, but what about the switch part of it? Peter?
If you have to have a metal part connected to it, and if you want to add 2 more batteries, they have to be this, like not the like the same exact size. It has to be like flipped over. One has to be with this like that bulb on top, and one has to be flipped over.
Okay, so you added a new component, but let's go back to the switch.
But a switch, it's a conductor that goes away from the rest of the circuit and goes back to make it go off and on.
Okay, so the switch turns something on
And turns it
when
off
what? When what happens?
when a whole circuit is
When the conductor, when all the metal parts are
together.
and the switch goes off, Owen, when what? When does the switch turn off?
When you put the light switch off,
It does, but what happens when we flip the light switch off?
the lights turn off.
They do turn off, but why? Why do they turn off, Sienna?
Because the wires are connected.
The metal parts,
Because the circuit's not completed.
the circuit is not complete. So let's try to put that again.
When all the wires touch and the circuit is completed.
The switch goes,
What?
and the switch
But
goes
when-
off.
when
When the switch
when-
goes off,
You take something out, like when you turn the switch down, it takes something out, and then the circuit is not completed, so the light bulb goes off.
and what kind of piece does it usually like take out?
Like a paper clip, or it's usually like a conductor,
Conductor piece.
because it wouldn't turn on if it was an insulator.
Right. If that piece was an insulator in there, would it matter if it was up or down or connected or not?
It'd be off no matter what.
It would be off no matter what. What's our evidence of this? What's our evidence piece? Yeah.
Electricity can't travel through insulators.
Okay, it can't travel through insulators. You know, Ian, you're kind of going on the lines of like our scientific reasoning, right? That's what science behind it. I'm talking about what evidence did we just do? What did we just do? I don't care if somebody shares the same switch you were going to share. It's okay. There's a lot of switches that we found. Some of you may have repeats, and they may look differently depending on how you put your little bits together. So we're going to quickly share what we discovered, and I may ask questions along the way. So Nathan and Stephanie, can you share what type of switches did you find?
Light.
Is your switch a light?
No.
Stephanie, what did you say?
A button switch.
A button switch. So what do you have to do?
Press it down.
One of your switches is to push it down. So let it go, Nathan. Now push it again. Okay, so one of the switches, but here's my question. Okay, Nathan, push your button. No. Push your button. Nothing's happening. Why? He's pushing one of his switches. Harper.
He has to turn the other one too.
Why? Because what's happening without it being turned on?
Because that's kind of like the off-on switch, or like if you just turn.
So if he's turning it on, what's probably happening inside the little bits? By turning this, what's happening? Peter.
The energy flows through the thing. It starts here, and then it goes. That thing lets it go. And then this thing doesn't let it go because this thing is on.
So when we turn it on,
it lets all.
it continues to let the
energy of the thing.
Yeah. What kind of energy?
Electric.
Which turns into what?
Light.
Which transforms into
Light.
light.